Hello, this is Felicity Ortiz, and this is my lesson on learning to measure liquid volume and mass. So before I begin, I just want to explain that I do not have any live students with me today. However, I will be teaching this lesson as I would talk to real students. But there will be times when I will have to explain how I would talk to, or how I would alter it if I was actually talking and interacting with real students. And here I will begin. So today we're learning to measure liquid volume and mass. Have you ever heard the word liquid before? And then I will wait for students to respond, and I will make sure to confirm whether or not they correctly know what liquid is. If they do say something like water, I will say yes. What makes water liquid? And then mass is probably something they may not be familiar with, so we will talk about that and what it means. For example, masses of object, what does that mean? It's kind of how things take up space, and we usually measure it with weighing it. So for today's lesson, we are going to be learning about how to measure and the tools that we use to measure liquid volume and the masses of objects. We'll also be learning the different units that we use to measure these. And then at the end, we are going to do some one-step word problems that will be adding and subtracting things that have volume or mass. So up to this point, I know that you guys have probably learned how to measure lengths of time and learned how to count money and learned how to add and subtract length. For example, with rulers, you use those, use like centimeters or meters or inches. And I know that you guys have learned about that. So we're going to learn how to measure these different types of things. So here are some pictures of tools that we use to measure things. Have you seen any of these tools? For example, you may have used some of these tools in certain activities like cooking or baking. And then I will wait to see if students to share their responses. And if they say they have used it in a recipe with their mom or dad, I will ask them how they used it. Did they use it to measure liquid like water or oil or baking soda? And I'll talk about the differences. One is wet and one is dry. And you might use different tools based on whether it's wet or dry. We also talk about units. Do you know any of the names of the spoons? What do we call them? Because we do call them spoons, but they also have another name, more specific, like tablespoon, teaspoon, half teaspoon, quarter teaspoon. And we use fractions a lot to name these different types of objects. For example, you also may use a cup. And there's many different units. If you notice on the cup, there could be ounces, as well as cups, half cups, fourth cups. Sometimes they even have milliliters, which is another unit we're going to be learning more about today. If you notice on the lower right-hand corner, this is something called a graduated cylinder, and you might have seen this in either a science classroom or you will definitely see it in the future. Also on the bottom left-hand corner is called a beaker, and it's something else that you probably will or have seen in a science lab. In the middle we have a scale, and this case, this scale has grams and, I think it has grams and kilograms in it. Sometimes we don't see those very often in the United States, but because here we end up using pounds and ounces. You may have seen one of these in a grocery store or something similar. I'll ask them why they think, or if they have seen it, and why or how do they use it. I'll explain that the scales are usually to measure weight, and in a grocery store, a lot of times in the produce section, they'll have these scales, so that we know how much something weighs, because in grocery stores, sometimes we pay for each individual item, but a lot of times things are based on weight. So maybe something's like $1 a pound. So we have to measure how many apples or how many pounds is like your bag of apples, so you'll know how much it's going to cost you. So next, I want to show you a video, and this really explains the metric system and kind of like why it's important, because I know it's really confusing, especially when we're used to hearing things like pounds or ounces or cups, but those are not something that is part of the metric system, and it is actually really important that everyone in the whole world uses something or has some kind of way to measure something that's the same. And this video will explain about it a little bit more.
What does the French Revolution have to do with the time NASA accidentally crashed a $200 million orbiter into the surface of Mars? Actually, everything. That crash happened due to an error in converting between two measurement systems, U.S. customary units and their SI or metric equivalents. So what's the connection to the French Revolution? Let's explain. For the majority of recorded human history, units like the weight of a grain or the length of a hand weren't exact and varied from place to place. And different regions didn't just use varying measurements, they had completely different number systems as well. By the late Middle Ages, the Hindu-Arabic decimal system mostly replaced Roman numerals and fractions in Europe. But efforts by scholars like John Wilkins to promote standard decimal-based measures were less successful. With 250,000 different units in France alone, any widespread change would require massive disruption. And in 1789, that disruption came. The leaders of the French Revolution didn't just overthrow the monarchy. They sought to completely transform society according to the rational principles of the Enlightenment. When the new government took power, the Academy of Sciences convened to reform the system of measurements. Old standards based on arbitrary authority or local traditions were replaced with mathematical and natural relationships. For example, the meter, from the Greek word for measure, was defined as 1/10,000,000th between the equator and North Pole. And the new metric system was, in the words of the Marquis de Condorcet, for all people, for all time. Standardizing measurements had political advantages for the revolutionaries as well. Nobles could no longer manipulate local units to extract more rent from commoners, while the government could collect taxes more efficiently. And switching to a new republican calendar with 10-day weeks reduced church power by eliminating Sundays. Adoption of this new system wasn't easy. In fact, it was a bit of a mess. At first, people used new units alongside old ones, and the republican calendar was eventually abandoned. When Napoleon Bonaparte took power, he allowed small businesses to use traditional measurements, redefined in metric terms. But the metric system remained standard for formal use, and it spread across the continent along with France's borders. While Napoleon's empire lasted 8 years, its legacy endured far longer. Some European countries reverted to old measurements upon independence. Others realized the value of standardization in an age of international trade. After Portugal and the Netherlands switched to metric voluntarily, other nations followed, with colonial empires spreading the system around the world. As France's main rival, Britain had resisted revolutionary ideas and retained its traditional units. But over the next 2 centuries, the British Empire slowly transitioned, first approving the metric system as an optional alternative before gradually making it official. However, this switch came too late for 13 former colonies that had already gained independence. The United States of America stuck with the English units of its colonial past, and today remains one of only 3 countries which haven't fully embraced the metric system. Despite constant initiatives for metrication, many Americans consider units like feet and pounds more intuitive. And ironically, some regard the once revolutionary metric system as a symbol of global conformity. Nevertheless, the metric system is almost universally used in science and medicine, and it continues to evolve according to its original principles. For a long time, standard units were actually defined by carefully maintained physical prototypes. But thanks to improving technology and precision, these objects with limited access and unreliable longevity are now being replaced with standards based on universal constants, like the speed of light. Consistent measurements are such an integral part of our daily lives that it's hard to appreciate what a major accomplishment for humanity they've been. And just as it arose from a political revolution, the metric system remains crucial for the scientific revolutions to come.
So at this point, I will ask the students what they thought of the video, if there was anything confusing, or how, and then we'll talk about it and explain and review kind of what I said in the beginning of like why it's important that we all kind of use the same thing, because everyone kind of uses different things. Like in the UK, I think pretty much everyone uses kilograms, but they use stones as well to measure weight. And here in the US, we use pounds, and that's kind of like not the standard. And it, like in the science community, everyone needs to use a standard. Otherwise, there could be mistakes that could have very bad consequences. For example, like if they're creating a rocket and someone uses a different unit of measurement to measure something, and then they say, oh, how much did you use, or something like that, they could end up crashing the rocket, or some people could die. So that's why we use this. We need to learn the metric system, at least so that we know or are familiar with it.